Hey, welcome to The Explainer. Today we're diving into a research paper that tackles a huge, and I mean huge, security challenge that's probably hiding in your own home. We're talking about all those smart devices, from your watch to your thermostat. Our world is getting more and more connected, but is it actually getting any safer? Let's find out.
All right, let's just jump right in with a number it's pretty staggering. The research we're looking at kicks off with this forecast. By the year 2030, we're expected to have 50 billion connected Internet of Things, or IoT devices. To put that in perspective, that's more than 6 devices for every single person on the entire planet.
And these devices are absolutely everywhere, woven into the fabric of our lives. They're in our homes, making things convenient, in our hospitals, monitoring patients. They're managing traffic in our cities and making sure packages get where they need to go. They are constantly sensing and sharing just massive amounts of data, all in the name of efficiency.
So what if your toaster could launch a cyber attack? Sounds kind of ridiculous, right? But that's the thing. The paper makes it crystal clear that with this crazy growth comes a massive and, frankly, often ignored security risk. Every single one of those billions of devices is a potential doorway for an attacker to walk right through.
So why is this happening? Why are these smart gadgets such a playground for hackers? Well, the research points out that it's not just some simple oversight or a mistake. The answer actually lies in their fundamental design.
And this chart right here, it just lays it all out perfectly. Think about your laptop. It's got tons of processing power, loads of memory. It's built to handle heavy-duty security software. But a little smart sensor? It's a totally different story. It's got to be cheap, small, and barely sip power. It's a specialist, not a security fortress.
And because of those built-in limitations, they become really easy targets. As you can see, attackers can just flood them with traffic to shut them down. They can listen in on everything they're saying, or just straight up steal the sensitive data they're collecting. These aren't just theories. They can cause major, real-world problems.
Okay, so how do we fix this? What's the solution? Well, what the researchers in this paper are proposing is a really smart, lightweight security system. Something that's clever enough to spot threats, but also efficient enough to run on these tiny, limited devices.
It's called an intrusion detection system, or IDS for short. And honestly, the best way to think about it is like a digital security guard that's constantly on patrol. Its main job isn't to build a bigger wall to keep attackers out, but to be smart enough to spot them the second they get inside, by watching everything that flows in and out of the device. So here's how their model actually works, broken down into 4 main steps. First, it grabs all the network traffic. Then, it kind of cleans it up, filtering out the noise to focus on what matters. After that, it uses a machine learning model to analyze everything, learning what normal looks like so it can instantly flag anything that seems off.
Now, a theory is just a theory, right? You got to put it to the test.
So that's exactly what the researchers did. They threw their model into a super realistic simulation of an IoT network that was actively under attack.
And to do that, they used this specialized data set called IoT. This is really cool because it's not just a bunch of random data, it's been specifically built to mimic a real-world environment, packed with both totally normal IoT traffic and a whole bunch of different simulated cyber attacks. It's basically the perfect training ground for their digital security guard. And get this, they didn't just run the test one time and call it a day. As the paper points out, they used a really tough testing method called K-fold cross-validation. What that means, in simple terms, is they tested the model over and over again on different parts of the data. This is how they make sure the results are legit and not just a one-off lucky guess.
All right, so this is the moment of truth. After all that rigorous testing, how well did their digital security guard actually do its job? Let's get into the results. Okay, let's start with the headline number, 97.4%. That was the average score the model hit across all the key performance metrics. We're talking accuracy, precision, the whole shebang. That is really, really good.
And when you drill down into the details, it gets even more impressive. Look at this. It was perfect, 100% at spotting normal, safe traffic. That's huge, because you don't want a system that's constantly crying wolf. And for the actual attacks, it scored incredibly high, over 95% on everything from data theft to those big denial-of-service attacks.
So how does this stack up against the competition? Well, when you put it next to other recent models that the paper mentions, it's right up there at the top. This shows that it's not just a good idea, it's a genuinely powerful, highly competitive approach to solving this problem.
One thing I really like is that the paper is super upfront about what's next. The results are excellent, for sure, but they're not perfect. The researchers know there's still work to do. They're already planning how to make the system even smarter, how to get it to catch even more specific types of attacks, and really push that accuracy score as close to 100% as possible.
You know, this research really is a powerful piece of the puzzle. It's a huge step in the right direction, and it shows us that with intelligent design, even our smallest, simplest devices can be protected. Which really leaves us with one big, crucial question to think about as we keep building out our connected future.